Hey guys, so welcome back. This is the lab lecture 7, so reactions virtual lab 8. This is the one that we're talking about today. I'm going to go ahead and share my screen so that we can talk about this. And let's see what we're taking a look at. So if we go into student view on this, you'll see this is reactions. You can do this as many times as you need to. We'll go ahead and start this. And physical observations can indicate that a chemical reaction has occurred. So we're going to be looking at precipitation reactions here for the most part when we talk about this. I expect that you'll read all of this stuff. This is about balancing equations. So examine the appearance of each solution before mixing. All right, so I see one of them is colored, the rest of them are clear. Okay, so appearance of NaOH and NiNO3 minus. So the NaOH is here, that's clear. The NiNO3 minus is blue. Nickel nitrate. Okay, now to a clean test tube, add dropper full of each solution. So I add the NaOH, put that back, add a dropper full of this, I put that back, and I can check the temperature as well. Now it doesn't feel hot, but I do see this solid has formed. So solid formed in the mixture. Didn't feel cold, didn't feel hot, didn't change, no bubbles. So select the products. And remember, this is a double displacement reaction. So I would expect that Na would end up with NO3. Since Na is positive and NO3 is negative, I would expect that to be NaNO3. Okay, but NaNO3 is not a solid. So I would not be choosing this one right here, I'd be choosing this one. Now the other one that I would expect, we would have Ni and OH. Now, if I look at my solubility rules, and I can use the ones that they gave me, I think that there is a link to the solubility table. So you can look at their solubility rules. And what you'll see if you look at water insoluble, compounds containing the hydroxide ion. So specifically listed here, right? So that, except for all of these. So since it's a hydroxide and it's not one of those, then that would be something that I would expect to be a solid. So I would choose the NiOH, and it's NiOH2 because I need 2 hydroxides if Ni is 2 plus. This one and this one. That better be right. Oh, sorry, not aqueous. There we go, that one. Pick the wrong one. No, pick the one that was solid, not aqueous. So that's what you're going to be doing for this. So what you should be doing, the way that you should handle this, is to write this down on paper. NaOH plus NiNO3 2, and what that gives you. So I'm going to go ahead and open a piece of paper and let you guys look at this. So again, I have NaOH aqueous being added to NiNO3 2, and that's aqueous. Okay, I know that I'm going to do a double displacement. And so I'm going to end up with an Na with NO3. Now, Na is a +1, NO3 is a -1. So that looks like NaNO3. Okay. I know that when I do my other one, I'm going to have an Ni. Ni is 2 plus, and I know that because NO3 is 1 minus, and there are two of them. Okay, so that's a 2 plus, and then I have my hydroxide, which is a 1 minus. So I'm going to need to have NiOH2. I know that this one is soluble because my solubility table tells me that. Okay, so when I looked at those solubility tables, it says NaNO3, water-soluble compounds containing an alkali metal. Na is one of those alkali metals. And of course, NO3 is also soluble. So this is soluble. This one is not. And that's because of the hydroxide there. Okay. So this is aqueous, and this is a solid. And let me pull this back up so you can see what I'm doing. And that's a solid. Okay. For each one of these, I would do the predictions. So when we talk about the next one, you'd be looking at NaCl, and that's aqueous, plus HC2H3O2. And that's going to give me double displacement. Again, I'm going to end up with the Na, and it's Na plus, and then I have a C2H3O2 minus. That's the acetate ion. So that says NaC2H3O2. And then I have my H going with the Cl, right? If I look at my solubility tables, oh, gee, it'd be helpful if you could see that. Going with the Cl. And then I can look at my solubility tables to see if everything's going to be soluble. So again, looking at my solubility tables, I know that chlorides are soluble unless they're with these. So that HCl is definitely soluble. I know that both of these are soluble because this is an acetate ion. So that acetate ion is soluble. And of course, the Na plus and the acetate are soluble as well. So this is an AQ. So I would actually expect that nothing's going to happen when I mix these two things together. Okay, nothing that I can see anyway. So let's go out and take a look. Chemicals for disposal, put that in a wash, we get a clean beaker, and then this is our next one. It's clear, and this one's clear. We mix them together. Oh, so, oh, I mixed the wrong things. Hold on. I mixed potassium iodide with lead 2 nitrate. That's not what I was supposed to do. That was this one. Oh, I skipped one. That's why. Oops. So I did form a solid there. It was not hot. When I did this, okay, again, looking at my Ki, write this down, Ki plus PbNO3, 2. Now, remember, potassium is a +1. I is a -1. It's a Pb2 plus 2NO3 minus. That's my breaking down of those ions that are present there. Okay, so that's what we're looking at for this. Now, both of these were soluble. This one's soluble. This one's soluble. This one's soluble. And this one's soluble. Now, I'm going to take that K and put it with the NO3 minus. So that's KNO3. I know I need 2 NO3s, so I'm going to put a 2 in front of that. And if I do that, then I'm going to need 2 of those. which would give you a 2 there and a 2 there. Okay. The other product that I have is a PB, which is a 2 plus, and an I minus. So that's going to be PBI2, and that is the one that is solid. It is a solid. And again, it's a solid because my iodine is soluble except when it's with a Pb2 plus. Okay, so that is a time when that is not going to work. That's why we get the solid that we formed. Solid in the mixture. I end up with PbI2 solid, and then KNO3 aqueous. Okay. Now, you don't have to predict these products. You can do it after the fact. That's perfectly fine. It's entirely up to you how you decide to handle it. But that's what this lab is designed to do, is to ask you, what are the solids that, or what are the products that you're going to form, and are they solid or are they aqueous? Okay. Remember that when I do this from the ionic sense because it's easier for me to see this is a K that's aqueous. And over here, this one, since he's aqueous too, I'd have 2K plus 2I minus plus PB2 plus 2NO3 minus, all of these being aqueous. I started it this way, and that gives me 2K plus aqueous plus 2NO3 minus aqueous plus PBI2 solid. Okay, and remember, our net ionic equation is only the ones that are involved in forming that solid, this guy right here. So my I and my PB. So the Ks didn't do anything. They're spectator ions, so we can ignore those. And the nitrates didn't do anything, so we can ignore those. So if I were asked to write a net ionic equation, that'd be and when we write our solids, we always put the positive ion first. Cation always goes first. Anion always goes second. It's entirely up to you how you do it on the other side. Doesn't really matter to me. Perfectly fine to write it this way. Perfectly okay if you flip them around. Okay. In this sense, I want to see where they came from. But when you write this one, if you flip them, it's no big deal. Okay. So that is everything with the double displacement reactions. So that is just about writing those reactions. I want you to practice with the reactions. Okay. Exam 2 is going to have a lot of these. So make sure that you're ready to predict products. Make sure that you're ready to have an observation. What is this going to look like when it goes together? So practice predicting with the solubility tables. Practice deciding how your double displacement goes and what your acid and base, your two products will be. Okay, I'm going to skip there. So I'm going to stop sharing now, and I will see you guys soon. Thanks.